However, this method of computing a score poses two main problems. Longer sequences are more likely to find higher scoring pairs. Longer databases are also more likely to result in higher scoring pairs. And so, one of the considerations BLAST came up with is to convert probability values to expectation values. So what is an E-value? The expected value, or expectation value, is the number of times that an alignment as good or better than that found by BLAST would be expected to occur by chance, given the size of the database searched. The idea is that what is the expected frequency that we would find this alignment in the database just at random. The E-value is basically the length of the database multiplied by the length of the sequence multiplied by the probability multiplied by some scaling factors. E-value is dependent on the length of the sequence and the length of the database. As the database grows, the E-value will change. E-values cannot be directly compared when searching different databases. Even identical alignments from different databases will result in different E-values. In a BLAST result, you may sometimes see an E-value of 0.0. An E-value less than 1e minus 179 is written as 0.0. Another prominent statistical indicator you will see in a BLAST search result is the bit score. A bit score, written as S prime, is a normalized raw score that is independent of the search space. The size of the search space is proportional to the product of the query length, sequence length, and the sum of the lengths of the sequences in the database. And so, the bit score measures sequence similarity independent of the length of the query sequence and the database size, and is normalized based on the raw pairwise alignment score. It lets you estimate the magnitude of the search space you would have to look through before you would expect to find a score as good or better than the one you have by chance. It is linearly related to the raw score, and the higher the bit score, the more significant the match is. As it's a measure of the alignment, a bit score provides a constant statistical indicator for searching different databases of different sizes, or for searching the same database at different times as the database enlarges. In other words, the same alignment may have different E-values if searched using different databases, but will have the same bit score. I'd now like you to pause the video and take a few minutes to reflect on what we've covered so far. You may use these questions on the slide to spark a discussion in your classroom. Once you're through, you can carry on to the next video.